Galileo Galilei. When you hear that name, what comes to mind? For a lot of us, it's this picture of a lone genius, right? Staring through a telescope, taking on the most powerful institution on Earth. And yeah, it's the ultimate story of science versus authority. But the real story? Oh, it's so much more interesting. Because at its heart, this whole thing is really about a new way of seeing. It's about how one person with a brand new tool didn't just find new things up in the sky, he literally discovered an entirely new way to figure out what's true. Okay, so to really get just how revolutionary Galileo was, we have to kind of step back in time. We have to understand the world he was born into. And for over 1,400 years, everyone in Europe just knew how the universe worked. It was elegant, it was divinely ordered, and, well, it was completely wrong. This was it, the official, accepted model of reality. And at the very center of everything, that was us, on a flawed, imperfect Earth. And spinning around us, in these perfect heavenly circles, were the celestial bodies, flawless, eternal, and made of some kind of divine stuff totally different from anything down here. You see, this wasn't just an astronomy model, it was a whole philosophy. The universe was basically split in two. You had our messy, chaotic, changeable world down here, and then you had the perfect, divine, unchanging realm up there. And the key thing? Truth wasn't found by looking at the world, no. It was found by reading the old books, the ancient masters, people like Aristotle. But then, in the early 1600s, this little invention from the Netherlands finds its way to Italy. They called it a spyglass. Now, for most people, it was just a cool toy. But in the hands of Galileo, it became a weapon against 1,400 years of absolute certainty. And boy, did things move fast. We're talking about a period of just over a year where Galileo just systematically dismantles the old universe. He wasn't just sitting around theorizing, he was looking. He published his findings in this blockbuster little book called The Starry Messenger. And seriously, the world was never going to be the same. I mean, you can just see the power of his approach right here. For every single ancient rule, Galileo had a direct, visual knockout punch. The moon isn't some perfect, smooth orb. Nope. Look, it's a rocky world just like ours. The heavens don't change. Well, the sun's got spots, and they're moving. And maybe the biggest shocker of all, not everything orbits the Earth. Jupiter has its own moons. The old model wasn't just cracked. It was completely broken. But here's the thing. Galileo's discoveries were really just the symptom of a much, much deeper revolution. He wasn't just changing the map of the cosmos, he was changing the rules for how you're allowed to make the map in the first place. This quote, this gets right to the heart of his big idea. Galileo was arguing that to understand reality, you can't just rely on what some guy wrote down 1,000 years ago. You have to read the book of nature itself. And this is the kicker. He insisted that this book wasn't written in Latin or Greek. It was written in the language of mathematics. And this right here, this is the core of his legacy. He basically established a two-step process. First, what he called sensible experience. Go observe, run experiments, gather the data. Don't just believe what you're told. Then, step two, apply necessary demonstration. Use the pure logic of math to figure out what your observations actually mean. This, right here, was the birth of the scientific method as we know it. So, proposing a new way to find truth is one thing. But when that new truth directly contradicts the most powerful and established institution on the entire planet, you're basically heading straight for a collision. The conflict wasn't as simple as we often make it out to be. It wasn't just science good, religion bad. Cardinal Bellarmino, who was a top theologian, didn't just say, "You're wrong." His argument was more subtle. He basically said, look, this sun-centered model is a fine hypothesis for doing your calculations, but to claim its physical reality, that requires a way higher standard of proof, especially if it means reinterpreting scripture. It was a really serious debate about what counts as evidence. But Galileo, he was convinced his evidence was enough. He pushed, he argued, he published, and eventually the institution pushed back. And they pushed back hard. He was summoned to Rome, put on trial by the Inquisition, and forced to answer for his challenge to the way things were. And this was the result. An old man, literally on his knees, forced to publicly renounce the work of his entire life. He was sentenced to house arrest, and that's where he would stay until he died. I mean, it seems like a total and complete defeat. But it wasn't,
Because you can silence a man, sure, but you can't put an idea back in the box. Especially not an idea about how to find more ideas. In fact, while he was under house arrest, Galileo wrote one of his most important books ever, laying the groundwork for modern physics. So his real victory wasn't just about proving the Earth moved. It was about establishing the method, the way we could prove anything about the natural world. He showed us that the laws of physics aren't different up there and down here. They're the same everywhere. They are universal.
There's this great legend that after he was forced to take it all back, Galileo muttered under his breath, "Y per si muove," and yet it moves. Now, did it actually happen? Probably not. But you know what? It doesn't even matter. That phrase perfectly captures the spirit of his work, that no amount of authority can change what's real. The evidence, the facts, they're eventually going to win out. And this is why Galileo's story is still so incredibly powerful. It forces us to ask ourselves, right? What are our modern-day certainties? What are the things we believe just because we've always been told they're true? And maybe more importantly, are we brave enough to look through our own telescopes, whatever they may be, and see for ourselves?